The universe must be flat. Why? Well, there are two reasons. There's the one I normally say, which is it's the only mathematically beautiful universe, which is true. But there's another reason I don't usually talk about, but I'll talk about here. It turns out that in a flat universe, the total energy of the universe is precisely zero. Because gravity can have negative energy. So the negative energy of gravity balances out the positive energy of matter. What's so beautiful about a universe with total energy zero? Well, only such a universe can begin from nothing. And that is remarkable. Because the laws of physics allow a universe to begin from nothing. You don't need a deity. You have nothing, zero total energy, and quantum fluctuations can produce a universe.
Let's assert that some kind of space-time quantum foam sort of something existed before our own universe began, before our Big Bang. Then we simply let Heisenberg's uncertainty principle go to work for us. If we look at the tiniest speck allowed by quantum mechanics, a small volume with a Planck length as its linear scale, the speck would have a volume of 10 to the minus 99 cubic centimeters. And the largest amount of mass, or energy, that we could put in this volume, without it becoming its own black hole, is about 1/100,000th of a gram. Interestingly, the uncertainty principle allows this much stuff to be created out of nothing for as long as 10 to the minus 43 seconds. Not a very long time, but it will prove to be enough. Because if that much energy is created in the form of a certain type of scalar field, then we have just successfully created a universe. The best model of how our early universe grew after that initial quantum fluctuation created it includes inflation, a period when the scalar field divides space into a brief period of extreme exponential expansion. During inflation, space erupted from its tiny beginnings into an unknowably huge volume. This enormous expansion generated an enormous amount of gravitational binding energy, at least 10 to the 85th grams. And this was counterbalanced by a corresponding group of positive energy in the scalar field. What began as a mere fraction of a gram of energy has now become 10 to the 85th grams. This is a huge number, large enough to account for all the matter and energy that exists today. But notice that the total energy in the universe is within a quantum fluctuation of equaling zero.